This is the 30 volt 5 amp power supply by UNI-T. All the knobs move smoothly. The controls seem high quality. Comes with little alligator clips and it connects with banana plugs. This is a regulated linear DC power supply. Measures 6.5 inches tall, a little over 4 inches wide, including the knobs. It's about 10 inches long. The displays are bright and easy to read. As soon as you turn it on, there's an internal fan that's constantly running. Gonna hook it up to my multimeter. Three volts on the power supply. Looks pretty good. 5 volts, 4.99. 9 volts, reads 9 on the money. 12 volts, 12 volts. And it maxes out 31.41, 31.43. This is the broken top part of an LED flashlight. These are 3 volt LEDs. There's like no illumination. So I slowly bring it up, they start to come to life. There's right at about 3 volts. Here's another 3 volt LED. This one I'm gonna just totally destroy. So there's 3 volts. It's got a nice bright blue. Go up to 4 volts. There's dead. Burnt out at 5 volts. Here I've got an ancient tape video recorder. The battery is dead. It says 6 volts. It has this thing that you can connect to it, and it's got some wires. I attach the alligator clips to it. So I adjusted it to 6 volts. And the camera works. This is my first power supply, so I don't fully understand how it works, but it seems to automatically sense the current that the device needs, because if I adjust the knobs, nothing happens. Here I've got a motor. This is from an old water pick. There's 1/2 volt. Three volts. And see, if I turn the current knob, nothing happens until I get way down low, and then it turns off. That's constant current, that's constant voltage. So it automatically senses what the device needs. I've got this old weather radio. It has a solar panel and a hand crank. And even if I crank it for about 5 minutes and leave it in the sun, the thing is totally dead. So I'm going to try to charge this battery. I kind of got the specs of the charging current off of this Panasonic charger. The battery is 3.6 volts. So I go up a little bit higher in the voltage, about 4.2, and then I'm going to trickle charge it at about 250 milliamps. And I'll keep an eye on it, and I'll touch it every 30 minutes or so, make sure it doesn't get hot. But I'll let it charge for an hour or two, and then I'll come back and let you know how it goes. Here's a look inside the case. I'm going to use a little Seek thermal camera to see what kind of components are heating up. Okay, so here's a look with the thermal camera. Here's the battery pack. It just barely feels warm, but you can tell it's charging. This is the center of the fan, 120 degrees as it spins. There's some transistors and capacitors right there. It's getting about 120 degrees. Okay, it's about 2 hours later. Battery is still warm. I've noticed the voltage has drifted up just a little bit, but now I'm going to reinstall it and test it.
Some thunderstorms may
It works.
rainfall this afternoon.
The little front flashlight also works.
Southwest winds 5 to 10 miles per hour. Chance of rain 70%.
So I give this power supply a thumbs up. I think it's a very good beginner's budget power supply. One of the main reasons I bought it is because it's so small compared to other power supplies. Thanks for watching.